Hey, this is Leach with Simpson Math, and in this video I'm going to be just doing a little bit of a demonstration of discrete random variables about how to find them, how to find their mean and their standard deviation. I'm going to be showing you two examples, one with roulette and one with a little bit of a hobby business thing that my husband and I have here at Simpson Math. We make enamel pins, and so I'm going to be showing you how to do the mean and standard deviation of that. So I'll demonstrate the video, on the first one up on the video, I'm going to demonstrate how we do it by hand and just kind of understand just some of the math. And then I'll show you then how to do it in Excel on the TI-84. And then I'll also show you on Desmos, though it's not great there, but I'll show you those three tech options. So let's get started with the problem. So here, let's just talk real fast through roulette. You might be familiar that it's the game where the croupier puts a ball and the wheel spins around and around, and it will stop at some spot. And if wherever the ball stops, if it matches what you bid, then you win. If it does not match what you bid, then you lose. So let's say that you were bidding $1, just a $1 chip. Let's say you put it over here where I have it indicated. So you put a chip right there in the corner of these two pieces. So what that's saying is you're betting that the ball is going to land on 23, 24, 26, or 27. So if the ball does not land there, then that chip just gets swept away by the croupier. Croupier is the fancy French word for the dealer, but there's no cards here, so the chip gets swept away and you lose $1. But if the ball does land on one of those four numbers, then you win. And the odds of this particular bid are such that you would win $8. Now that $1 chip that you bid comes back to you, so you get to keep it. And then the croupier will give you 8 additional chips or 8 more dollars that you can then play with. So there ends up that there's actually 38 slots on this is American roulette. So there's 38 slots on American roulette. So I'm going to say that the probability of you losing is pretty big. It's 34 out of 38 because there's 34 slots that you could lose on. Notice there's 1 to 36 total numbered slots, and then there's an extra 0 and double 0. Those zeros and double zeros are really how the casino makes their money, because for the most part, if it lands there, you're probably not going to win unless you happen to bid specifically there. So then there's 4 options out of the 38 that will let you win. Notice that this probability model is a valid discrete probability model because one, we're dealing with these numbers here, but then each of these probabilities are valid probabilities. They're discrete, they're separate from each other, and a big thing, if I add them up, they equal 1. So this is this model. We're going to talk about trying to find the mean and the standard deviation of this. So what is the average amount of money that you would win or more likely lose, because this is gambling, when you're playing roulette, and then also what's the standard deviation of that. So here are the formulas for the mean. So that's the formula for the mean. When we're dealing with discrete random variables, we're often talking about them being the expected value. So this E of x, I read this as the expected value of x. It's the value that you expect to get on average. Or you can use this mu symbol. That's the lowercase Greek letter mu. If you were to spell it out in English, it would be mu. You draw that by drawing a U with a kind of a little tail on the left. If you look down below me and in the image, you'll see our Simpson Math logo. The S is actually an integral. That's from calculus. And then the mu is representing, that m is representing this mu, or the mu is representing our m for the SM for Simpson Math. So that's kind of the stat part of our Simpson Math logo, is that mu. So then that's our mu. It has this formula. So let's analyze this formula real fast. So let's actually just do it. So we're going to find the sum of the product of these two x's. So basically, you're just going to take your x, multiply it times the probability, add it to the next x times its probability, and that's what this is saying. So go to your first x, which is -1, multiply it times its probability, which is the 34/38. Then plus, go to your next x, which will be 8 times its probability, 4 out of 38, and you add them up. Let me just point out that on this formula, sometimes, in some cases, you might see a little subscript I. That's just called an index or indice, if you want to make it be plural. All that's saying if you see a version of this formula with those i's, it's just saying this first one, pair the first x with its first probability, pair the second x that you see with the second probability, so forth. So it's just pair each x up with its buddy, the first with the first, the second with the second, if there's more, the third with the third, fourth with the fourth, so on. All right. So then, when you end up, you can just throw this in the calculator. You can do them in 2 different bits. I'll show you how to do a more proper way in the calculator in a minute. But even if you don't use either of those methods, you can just simply multiply -1 and 34/38 and multiply 8 times 4/38, add them together, and it turns out to be this actually nice fraction of a -1/19, or approximately just over a nickel, 5.286 cents, or $0.0526. So notice in roulette you are expected to lose. So basically for every dollar that you bet, you're expected to go down to lose a nickel. Notice you can't, or just over a nickel, notice you can't lose negative $0.0526 every time exactly, because you're either going to lose $1 or gain 8. But at the end of the night, if you just made this bet over and over and over and over again, that would be your average losses, your average gain, but it's actually negative, so how much you would actually lose on average across the night. Turns out, pretty much all, I think it might actually be all roulette bids in American roulette actually have the exact same expected outcome, which is kind of interesting. You're pretty much always guaranteed to lose that nickel, or not guaranteed, you're expected to lose that on average. A little bit just extra, I really made this video for to demonstrate the technology, but couldn't resist myself. I wanted to show off just a little bit of helpful understanding of this formula, why this formula makes sense. So let's just say that I wanted to average up, I have 34 ones and 4 eights. So imagine I had those numbers, 34 negative ones rather, and 4 eights, and I just wanted to average that up. So I would do -1 plus -1 plus -1 plus -1 over and over and over and over, specifically 34 of them. So I'd add up those 34 negative ones, and then 8 plus 8 plus 8 plus 8. I can summarize that repeated addition as multiplication. So that's -1 times 34. That's the same thing as what I have up here. And I can show that I have 8 times 4 is this just 8 plus 8 plus 8 plus 8. All right. It's a little bit of slightly advanced math. In terms of thinking about fractions, this kind of freaks some people out, but I'm unadding the fractions. So if you watch my camera, it's like I have 2 fractions. Here's my common denominator on my pinkies, and I'm unadding them. I'm just going to break them apart. Notice if I went backwards and added them up, I would have, I already have a common denominator, so there's my common denominator, and here's my numerator, and I just put them together, added them up. So if I can add that way, I should be able to kind of unadd them in the other direction, kind of break that fraction apart. All right, so I've broken the fraction apart. And then one last little maneuver is you can think of this as a -1 over 1 times 34/38, -1 over 1 times 34/38, or just -1 times 34/38. Same thing with the 8. I can kind of think of this as 8 over 1 times that, because 8 times 4 is this, still an 8 times 4 right there. And if you want to kind of think there's an over 1, well, there's an over 1 right there. 1 times 38 is then just that 38, this 30 right here. So notice I could rearrange this multiplication. Instead of having two values in the numerator being multiplied together over one denominator, I can rearrange it so I have just one number being multiplied by a fraction. And notice that this is exactly what we did up here. This is that formula. So hopefully this might be helpful for you to see that this literally is us just finding the average of those items, but a nice, just quick, efficient way of doing it. All right, next we're going to talk about doing these standard deviations. So let's look at these formulas. So first, when you find the standard deviation, you should go ahead and calculate the variance, and then once you have the variance, then square root that, and that will get you the standard deviation. There's a few layers for this, but a big thing is that within random variables, there's a rule called variances add. So you have to add them together as variances and then square root them. So if I somehow wanted, you notice we have to add them together to get the variance, and then we square root. If you just square root each one individually, Notice how the square root is in the formula. It's after we add them up. If you square them individually, that would not turn out right. That would be you adding standard deviation. So it's a big no-no. But let's think about just the logic of this formula real fast. I'll show you under the square root. So back when you learned early, when you just learned probably regular in your stats class, you probably just learned regular standard deviation stuff. And so your first thing you learned when you made the standard, if you might have learned how to do the standard deviation by hand, you calculate first the deviations. But what happened, the deviations is the distance and direction that these values are away from the mean. So you do the x minus the mu, that's the deviation. Then if I add up all those deviations, remember, the sum of all those deviations will always and forever be 0. That's because the mean is a physical balance point of your distribution, and so it will always, I don't care what distribution you give me, if I find the mean and then all the deviations, add them up, it's always going to be 0. So one way that we fix that is by squaring it, and that's the process with the standard deviation, is we square it. So then I would square them, so I have all my squared deviations. We would then add up those squared deviations and then divide by our number of things we have. This p of x, between the p of x and my sum, this capital sigma is the sum of, so it tells us to add everything up. Between those two things, that's going to take up, that's our division, because there's p of x's have our denominators, and also the numerators tell me how many times we have each of them. So this takes care of the how many times we have each one, and then I'm adding them up and then dividing by my number of things. So this really is the same standard deviation formula you learned previously, just kind of rearranged and adjusted when you know the associated probabilities. So let's see how we would do it by hand. So here I have this I've just copied our information down. So I'm going to find the variance first. The variance first is denoted by this symbol. It's a lowercase sigma. This is the capital sigma. This is the lowercase sigma. When I draw this, there's a few ways that you can do it. I like to draw it like I would, just probably lowercase o in that direction, and then put a little like flip on it. So there, and then line out. Make a loop, line out. Some people will start on the far side and swoop in. That is also fine. They'll just kind of do one little, oops, I'm drawing it badly, like this. I don't usually do that, so I'm doing a bad job on it. Make a little lowercase o, and then flip it. Alright, it's like a little, like my hair, this guy flips out. Alright, so we're going to find our variance of x. So first, within this formula, you take your x, so that x, minus our mean, that negative 1/19th, and that gives us our deviation. Notice in this case we are subtracting a negative, so it actually ends up being a negative 1 plus 1/19th, but I'm just kind of blindly writing that in. We then square it, and then multiply times its probability. Then do the same thing for the 8. So notice the only thing that's changed between these two segments is the 8 and the probability. The minus, the mean, squared, all that's the same. You can just, in a calculator, especially if you're maybe on Desmos or on an 84, you can just type these in so you can see them. My even little Casio scientific calculator could handle this well because it has nice math type. So you can always just type it in, be mindful of all of your parentheses, and then you'd end up with about 7.6288. Then we got to square root it, because this is right now the units here would be like squared dollars, which is not the unit that we want to mess with. So we're going to square root it to get it back to just being dollars. So we square root it and we get to be about 2.7620. So again, just an interesting thing about roulette, I said that all bids, all $1 bets had the exact same expected outcome of losing just over a nickel. What's different though is the standard deviation. The standard deviation is what changes, and obviously the more you bid, the more you might win, but also the more likely you're going to lose, and so that will expand, and as your bids get rarer and harder to happen, your standard deviation will get bigger. Or if you made an easier bet like the 1-to-1s, one of the ones where you just bet on just even or black or something like that, those have a much easier payout, those have a much smaller standard deviation. Alright, let's look at the other problem, and we'll see that expanded for multiple outcomes. So the first one was we just had two things to deal with. So now this one I'm showing you because what happens in this case, I have 5 total possible x's. How does that change things up? So this is at Simpson_math. We design and sell enamel pins on our own website and on Etsy. They look, here's two of them, and grab two of them. They look like this. Let me zoom in on you. These are both pie of our pie pins. This is a apple pie and our green apple pin. This is a pumpkin pie. So those are some of them. You can see some in the screenshot up there as well. So our transaction history, this is not an ad, but I mean, buy from us. Our transaction history on Etsy shows that most customers buy just one pin in a transaction, but some customers buy more. The probability model of the number of pins purchased in a single transaction is below. I did kind of educationify this just a little bit, made it be academically sterile just a little bit, so that denominator is a little bit clean. There's actually nobody so far who's bought just 3 pins. We have people who've bought 4 and 5, nothing more, but 3 was kind of empty, so I kind of averaged things out and made them be nice, almost multiples of 5 for most of these. So there's our distribution. Notice this is in a transaction, so I'm not counting the people who came to our website, saw it, and went, nah, not today, or they just favored it and move on. So these are total of the people who have made transactions. So let's find our expected values and standard deviation. So it's the same process. So it's my 1 times a 0.75 plus the 2 times a 0.15. Then I'm going to keep that pattern going. 3 times 0.05 plus 4 times 0.04 plus 5 times 0.01. But that's a lot of writing. So a little trick in math, not even just a trick, just common practice, especially if you have the information above. You do 1 or 2, you do usually 2, maybe 3, to establish the pattern, and then you say plus ... plus. This ... is an ellipse. You're saying keep the pattern going, but it does end. It doesn't go on forever. It does end. So then it's going to stop here at the 5 times the 0.01. When you do that math, so again, you can type it all into a calculator or use one of my techniques I'll show you in a second. You end up with 1.41. Oh, I forgot to say, I'll just go and say it now, that there should be chapters down below, so you can go ahead and skip towards your preferred method of Excel, the 84 or or Desmos. All right. So then for the the standard deviation, I got to find the variance first. We do the same thing that we did earlier. So we take our x, then we multiply it times the mu, then square it times its probability. Repeat that pattern over and over. Take the 2, take the next x, which is a 2, subtract it from the mean. Notice this one is above the mean now, so I'll get a positive number when I subtract. Square it times its probability. Keep that going. Do that for the 3, do that for the 4, and then so I have plus ... plus, and then I end with a 5. 5 minus the mean, square it times its probability of 0.01. You do all that and you end up with about, this actually terminates. The variance should often terminate because there's no square roots or anything like that. So as long as you don't round egregiously here, you probably should end up with a number that, not always, but you often should end up with a number that might have a terminating decimal or a number that can be written as a fraction. This number should be actually a rational number. But when you square root it, probably not. So I'm going to square root the 0.7019, and then notice it does get bigger. Remember, numbers between 0 and 1, really, I'm not worrying about negative numbers, but numbers between 0 and 1, because standard deviation variances will always be positive, they will actually grow when you square root them. It's the numbers that are bigger than 1 that when you square root them, they get smaller or closer to 0. So, all right, so that's how we do this by hand. I'm going to now jump to doing this in Excel. So let me pull up my Excel document on my computer. There it is. Let me switch so you can see it. Should be this one. All right. So, so with this, this is the one that is finished for the roulette, and here's the one that is finished for the pin cells. I'll show you how I do them. I'm about to I will do it with you. But if you want to pause it, if you're like, oh, I know Excel, all this makes sense to me, feel free to pause it or screenshot it for the roulette. And then I'll show you the pin cells again. So feel free to pause it or screenshot it for the pin cells. All right. Those of you who are still watching, haven't skipped ahead to the next chapter. Let me show you how to be able to do this. Oh, I didn't explain that in this bottom half, these are just the formulas kind of showing you. I'm printing what is up here. So notice this square root of f5, that is the formula that is here in G5. So that way, these things down here, you can see what formulas I'm using without me having to keep them up. So that's what's happening down below in the bottom part. Those are the formulas. When I build my spreadsheets, my kind of like calculators that I'm doing, I like to kind of build them where I highlight certain areas. So let me go back to the one that's done. So I like to highlight, here's my input area, and then here are where my answers are going to live. I don't usually have this. This is just for y'all. But I usually will at least have those areas. So I have clear highlighted area for this my work, and here's my answer. And sometimes I might color code some other parts if it kind of behooves me. So let's go through this. I need to first put in, I'm moving my thing so I make sure I know my the values. So I need to put in my values for x. I have just labeled this. I have to label the structure, and I'll explain this process as I go along. But so first, I want my x and my p. So A1 I put x, B1 I put p. P, I could also label this instead of p. I could label this p of x. That would probably be a little bit more proper. So I'm going to have a -1 and an 8. So I just typed in -1 and 8. It doesn't matter which order you write them in. What matters is that the probability for the -1 is next to beside the probability for -1. So if I type in, it's about to get angry. If I type in 34/38, oh no, it's actually happy there. So 34/38, it's cool. But if I do 4/38, it tries to turn it into April 38th, which that doesn't even exist. I don't know, is that April? Is that the year? I don't know. So what I'm going to do is I'm going to say equal to 34/38. So that way it really knows that that's a number. I'm dividing 34/38. I'm going to do the same thing. Equal to 4/38. So within Excel, if you don't know, in order to get formulas, you start off with an equal sign. Just equal sign, and then you can put in math, any math, or specific Excel formulas afterwards, and that's how you get those values. So there's our probability distribution. One thing I like to do is it's kind of just for safety's sake, on this calculator, I want to find the sum of these two numbers, just to make sure that they're 1. Because sometimes it's really easy to catch a typo by checking to see if my total is 1. And I'm going to be using this total anyway. So I'm going to say equal to, and then type out sum, S-U-M. And you can either take the formula by mousing over and clicking on it, or doing open parenthesis. I just like to press a tab. There's just a button that I can always press. So the tab says, yep, take that one. And so now it's saying, well, where are my numbers? So I'm going to come up and I'm going to click with my mouse, click and hold in cell B2, and drag down to cell B3. So that way it's created a range for me. You're going to want it to be a range and not just the specific two cells, because in a minute we're going to insert some rows to make the section bigger for when we do the one about our pin cells. And so you're going to want that range to grow with you. And then so press enter, and it will actually close that parentheses for you. And you can see the formula down here. All right, so we got 1, so we knew that was right. So if I had accidentally typed in equal to 6/38, notice this number is bigger than 1, and that is wrong. This number has to equal 1, because that's one of the rules for these for our probability distributions. Oops, it did it again. 4/38. Well, undo, because it was thinking that was still a date. Equal to 4/38. Okay, so now let's do the mu part. So I'm going to find my E of x parts. These are my E of x parts, and then I will add those up to get my total. So this is the x times p of x part. So I'm going to start with my equal to, and then I'm going to click on this cell that's my x, which is the A2, and then I'm going to do multiplication, which is just the asterisk. So you can do Shift 8, or if you have a number pad with an asterisk, you can press that, and then click or type in B2. I just like clicking because it just makes my life easier. Press enter, and there's our expected outcome for that part, that part's expected value. Nope, let me say that again. That's that part of the expected value formula. All right, I could do this again. I could say equal to this times this, and it would be fine. And notice I get A3 times B3, which is what I want. But I'm going to actually undo that, because you need to be familiar in Excel about filling down. So if you ways to fill down, you can move your cursor over here to there's a little square in the bottom corner. Press that, press and click, and drag down that's the preferred method that I use to fill down. You can also just highlight them and press Control D. That fills down. You can also highlight, and then up here, yeah, you can see it. There's a fill option, and then you can fill down, right, up, or left, and we're going to fill down. So either way you do it, 3 different ways to fill down. All right, next, I just need to add these up. Well, I already have this sum of these two. If I since the sum of B2 and B3 are referring to these two, if I copy and paste and move this over, it's going to be referring to the same two that I want. So I'm just going to copy this cell and paste it over. If you didn't want to do that, you could have just typed it in fresh. But notice if I double click on this, it changed the value, so it's not looking at B2, B3. It's looking at it's going up 3 from it and then down 1. So it kind of keeps in the same relative position to that cell. So there's my sum. And notice that minus just over a nickel is the same value that we got when we did it by hand. All right, so now we need to find the variance parts. I could do this in separate pieces. I could do a point where I find the deviations, and then do a point where I square them, and then do another column where we multiply times the probability, and then finally we add them up. I'm just going to do them all at once. So I'm going to say equal to, and then I need to, and I will do this in parts. I'll do this inside out just so it makes sense. I'm going to do a little bit of editing so that way, yeah, it'll make sense. So let me just start with that deviation. So if I'm going to open a parenthesis, though the parenthesis isn't 100% required for just the deviation, but we'll go with it. So I'm going to open a parenthesis, I'm going to select my x, and then I'm going to subtract. So I'm going to just put the dash or minus, they're all kind of the same in Excel. And I'm going to minus the mean, which is this expected value. Oh, notice my blue changed. I'll put it back to being blue in just a second. So then I'm just going to click on that. So that's going to subtract my my mean. And I'll go and close my parentheses and be done. Now that's not the variance part. That's just part of it. So there's one issue with this that I want to go ahead and address. Is that in a minute I'm going to want this. I'm going to want to do the second part. I'm going to want that second part to also refer to D5, but I'm going to do a fill down in just a second. So I want to adjust this D5 so it's going to always reference that that cell. Let me show you what would happen if I didn't change it real fast. So if I fill down my deviation, notice that this cell is now referencing this 8 and then this empty cell. I don't want it to do that. I want it to always be referencing this D5. So we're going to make it an absolute reference. So go back in the cell to edit it. And if you press F4 on your keyboard, it should cycle through the absolute reference options. Or you could just by hand type in the dollar signs. If there are dollar signs in front of both, it is locked down both vertically and horizontally. This one, just the dollar signs in front of the vive, so it would only affect the row. This one, the dollar signs in front of the D, so it's only going to affect the column, or it can have them all off. It doesn't really matter. I'm just going to have them both be locked down so that way I don't mess anything up, because I just don't want it to move at all. But there's sometimes some needs that you would want one or the other. All right, so there's our deviation. Then the next thing that we did to our deviation, we found our deviation and then we squared it. To get the square, you do the Shift 6 to get the caret, and then 2. This is why those parentheses were needed earlier, because I'm going to square that total subtraction. If you didn't have that parenthesis, it would be a problem. So let me just check to make sure that that one's happy. All right, so now I'm going to multiply times the probability. So let's do our asterisk for times, and then come click over in B2. So there's our probability. Let me kind of state, this might seem like, oh my God, he's having to do so much, but because it feels a little overwhelming right here. But in a minute, I'm going to show you how I can take this calculator that I've built, change it into the pin system, and then automatically get my E of x, variance of x, and my standard deviation of x. All right, so that should be, let me double check, look at the formula. Yep, my deviation squared times the probability plus the next one. So I'm going to drag down, fill down by your preferred method. I like to do the drag down. So notice that my formula did change to the correct values. You can even double check on it, and it will highlight and color code them so you can be like, oh yes, those are the right ones. And then I'm going to go ahead and fix my coloring on my E of x, just so that way it's nice and pretty. and I'm going to copy my sum over, just like we did before. So I'm going to copy and paste my sum. Alternatively, you could actually fill over and then delete that in the middle, but that's a little bit awkward. So I'm just going to copy and paste. So now it's the sum of those two. So there is our variance. And looking back at my stuff earlier, that is exactly what we had. So that's the variance of x. And then one last thing is that we need to find the standard deviation. So in this last cell, I'm going to say equal to, and I just need to square root this F5 cell, that's 7.6288. So I'm going to find the square root function, so just start typing at square root. But notice by the time you do SQ, you only have two options. And so it is this SQRT. SQ for square, RT for root. So square root. I'm just going to press tab. There we have our square root of, and what am I finding the square root of? This F5, I'll just click it, press enter, and there it took the square root of that cell. All right, so my calculator is built, and so that 2.776, checking my notes, yep, that's what we got earlier. So this calculator is functioning. Notice if maybe I was to do another bid like the, let's just do like a 1-to-1 bid. So let's, no, never mind. Let's just, I'm rambling. But let's say if we wanted to change this, maybe it wasn't you lose an 89% chance that you lose $1. Maybe it's just a 0.7% chance that you lose $1 and a 0.3, 70% chance you lose $1, 30% chance you gain $1. So if I change those values up, notice my total is 1 and everything else lines up. 1.7 is expected value, there's a variance, there's a standard deviation. Maybe it's not 8, maybe it's 5. Notice it all updates. So now you have a working, functioning calculator that you can just edit and change at will. All right, the other example was about the pins. So the reason why I included that was just to show you how do I go from 2 to 5. So I'm going to click in row 3, and when you insert in Excel, it's going to insert up. When you insert a row in Excel, it's going to insert it above. So in row 3, I'm going to right click and say insert. So it's going to insert a row. So it inserted a full row, and then notice what happened. One, my formatting stayed, my coloring stayed, but notice the formulas here are my sums. My sums are now from B2 to B4. Notice how they have been updated. This square root of F6 is now square root of F6 is now, it's still referring to the left thing. So that updated, and even it expanded that. So let's do that again. Go to the 4 or the 3, insert, and then do another one, insert. So notice these formulas have updated for this. My formulas down below are going to be a little bit off because it's not referencing the right thing, so I'm not worrying about that right now. I'm just going to worry about this. So now I can put in my data. So it's 1, 2, 3, 4, 5, and then my probabilities were, it was 0.75, let me check at it, 0.15, 0.05, 0.04, and 0.01. When I practiced this earlier, I had accidentally typed in 0.14, and I was like, yeah, oops, and then this told me, oops, Leach, you wrote it in wrong. And I was like, ooh, what did I do wrong? Oh, that one. That should be 0.04. So that was kind of a helpful thing. This total then saved me. Well, notice it's just a little bit broken. It's not working out quite right. That's because these are empty. There's nothing going on here. So when it's adding up, it's just adding up this top part and this bottom part. Over here, oops, escape. Here it's adding up this top part and this bottom part. That's not what I want. By the way, to get out of those cells, I'm pressing escape, so it's not accepting any changes, the change I accidentally made, or so I'm not clicking on any boxes to edit the formulas. So now I just need to fill down. So this one is good to go, and I'm going to fill this down so that way all of them add up. So choose your preferred fill down method, and voila, there's my expected value, 1.41. And then this one is referencing the correct expected value. So even when I did that, changing the rows by inserting, Excel is recalculating those formulas for you at its best guess of what it thinks you're trying to do. And so now I just need to fill down. Oops. And then so there's my variance and there's my standard deviation. which was the same thing that we got earlier when we did it by hand. So you see how quickly it is to go from 2 to 4. And if, let's say I was working another problem and I already have it built out, I already have it built out to these 5, what I could do is just press the delete key. If you press backspace, it just deletes the first thing. But if you press the delete key, I'm on a PC, so like there's a separate delete. If you're on a Mac, like function delete, I think maybe, I can then just edit these two. If this was 0.25, then everything adds to 1, and it's all good to go. So notice you can just have extra spaces, but if you did not have enough space, that's how you add it in using insert. All right, so that's Excel. Save this. I saved my discrete calculator for mean and standard deviation, just so that way I would have it and know what it is, and then you can pull it up when you use it. All right, let me show you how to do this I'll just leave this up here. I'll show you how we do this for on an 84. All right, let me turn on this 84. All right, so I'll have the answer right there so we can see if we get it right that third time. All right, so in the 84, you're going to go to Stat, and then Edit, because you're going to edit your data. So you're going to go to Stat, Edit. So we're going to edit our list. I had, just a second ago, I'd put in a 3 and a 5 just to show you, oh no, what if you have stuff already in there? Well, you could just press clear, and it would, nope, don't press clear there. You have to arrow your mouse all the way up to L1, and then press clear. Do not press delete here. So press clear. If you press delete, you'll literally delete. Let me just show you. If I press delete, it just deleted out L1. L1's gone. There is a way to get it back. On here, you would have to press second insert, and tell it that you want it to be L1. And it would remember what was there. If you even had stuff in there, it would even remember it. Or if you ever accidentally do that, just reset the calculator. 2 + 7 1 2. So press clear. That's how it clears out the values. All right. So now I'm going to type in our values. It was a -1. Make sure you use the negative, not the subtraction button. -1, and then 8. Arrow over, and then we're going to put in what's the probability? The probability is 34/38. So I'm just going to do 34/38 and 4/38. And notice it converts it to the to the decimals. That's okay. So now press second mode, which is quit. So second quit to get back to the main calculator screen. All right. So now that we're there, we're going to go back to Stat, but this time calculate. If you didn't go to the home screen, you might be putting in one of our stats into the list, which is weird. So do press one of our stats, and then it's asking, where's your data? Oh, well, my data is in L1. If for some reason you put it in another column, you can specify it. Down here on 1 2 3 4 5 6 are your 1 through L6, L1 through L6. But then here we need to put in the frequency list, which is second 2, which is it lived in L2, so do second 2 for L2. I don't know if the 84, if this is a bug or feature. I know at this point it's a feature because stats textbooks galore have embraced this fact, and when they move to the Inspire and other versions, they've used it. I don't know if it started as a bug or feature, but other calculators, online calculators and stuff that have a frequency list style way of finding one of our stats, if you do this on that, it breaks and it yells at you and it says, oh, frequencies have to be integers. So I don't know if it was intentional by Texas Instruments or not, but this works. So yay for it working. So all I had to do was put in my data in L1, my probability in L2, and we're going to treat that probability as a frequency list. Press calculate. It does a little thinking, and so then it calculates to one of our stats. So X bar, which is another symbol for mean, X bar is our mean. It's really our population mean, but here that is. Notice it should actually be the same thing as the sum. That's because our entire sum is 1, so if the way it calculates the sum, it's the same thing, because that's how we did it. We just added up all the parts. And then notice the standard deviation, the SX, it's blank, it's empty. That's because an error actually got produced because the total sample size it thinks is 1, because that's our frequency list, adds up to just 1. So if you were to divide by n minus 1, you're dividing by 0, so that's why that's empty. Which it doesn't matter anyway, because we're grabbing sigma, which is the population standard deviation. So it's 2.762, so there's that same value. So that's pretty quick and easy. So let's make a quick edit. So we can go back to stat edit, and let's change this to our other data values. You can clear it, or you can just type on top. I'm just going to type on top. 1, 2, 3, 4, 5. Go over, arrow up, and this is 0.75. This is going to be 0.15. Yeah, 0.15, 0.01, 0.05, 0.04, and 0.01. Alright, so second quit, stat, calculate, var1, stat, 1 var stats. And here it probably remembers that you had your frequency list in L2, and I still have it there. So I'm just going to say calculate. It thinks for a second, and there's my mean of 1.41. There's my standard deviation of 0.83779. Now, what if I needed to find the variance? One way is just to jot that number down and then simply square it. The more advanced way, just to show this off, this button vars, that is short for variables. So if you do vars, go down to statistics. The most recent thing you calculate, all those numbers just got stored as under these variables. So do you see sigma x? So I chose sigma x. I'm going to press enter just for good measure to make sure, yep, that's the right sigma x. Can arrow up, grab it, have it copy and paste it down, square that number, and there's my variance. And notice it even knows that it even is terminating to that 0.7019. So there is our sigma, our variance. So that's also how you can find the variance on there. All right. Lastly, let me show you how to do this in Discord. Nope, wrong D. Desmos. Okay, get my camera out of the way. So I'll put this Desmos calculator as a link in the description below. While you're there, don't hesitate to like and subscribe. But I'll put the link down there so that way you can just pull this up and use it. I'm also just going to show you how you can build it yourself. But notice here I have this set up already in the settings of our pin cells. And notice just how I'm getting it. I've found my mean, which is 1 point. Something's off. Oh, right there. That should be 0.0. There we go. I should probably add in a summer just to make sure that everything adds up to 1. That might make more. That might be a good idea. But make sure you type everything correctly. There we go. 1.41 is the right answer. So there's my mean. There's my variance, and it's taking that variance and square rooting it. So let's walk through the logic a little bit. So what's happening is actually let me show you real fast how to change out the data quickly. So I want this to be a -1, and I want this to be an 8. I don't need that 17. It was trying to skip count for me. And -1 was 34 out of 38, and this one was 4 out of 38. And so here's our correct information. All right, so just to show you how to change that up. So now for me, I did label it M. I just had to label it something because down here I'm using the M, so I'm referencing it. So the sum of, and you do have to be proper here, and with these indices, so I have to say that I'm starting at 1, which is just this first one, and going to, and this length of x1, that's saying it knows, oh, it's going from 1 to 2. This first one down just up to just the second one. Earlier when I had 5, it knew that it would start at 1 and go up to 5. So it's saying go to x1, and this in here, bracket in, is really the index. It's saying look at the first one and multiply it times p1 with its first one. So that's why we have to have that indice there. That's what that is for. Because you could have it multiply the first one times the next row down if you really wanted to, and that's why you're being technical and specifying it that way. All right, so then I use my m down here, and so this formula should look familiar. So it's my x's. This time I have to use a different value for the indices, so instead of n, I'm using I, which is another common value for the indice. That's why it starts with an I, index I. because if I use the in as well, I'm already using the in this calculator, so I'm having to use I. So I have I here, which is just treating as my index, so my first x minus the mean squared times the first probability, and then we'll do it to the second one, and then go up until it hits the length, which is 2 in this case. The length is the number of items in the rows, so it's just going to stop at 2, get the variance. I label it capital V. Desmos is case sensitive if you build this on your own, by the way. And so then you end up with s equals square root of V. So I labeled it S just for fun. I don't really need to label it S, but just so that way, casually when I'm looking at that, it's like, oh, S for standard deviation. I have a little bit of words explaining how I built it down there. Like I said, if you just use the link in the description below, you can just grab it and then pull it up and then edit it at your pleasure. Alright, so hopefully this was helpful to see discrete random variables explained a little bit more, and then also how to do it in technology. You saw how to do it in Excel in the 84, and then also here on Desmos. So I'm planning on making a few more, so make sure to check them out. I will see you in the next one. Bye.